Previously, you have learned about using the cross-product algorithm for factoring polynomials. So when you have something like this can be applied for any ax squared plus bx plus c, granted that a is always 1. So a couple very quick examples. If you have x squared plus ax plus, and we'll say that this is 12. The top of the cross product is the beginning times end, so that's 1 times 12, which is 12. And this is a middle term, which is 8. If we want to find out the factors of 12 that adds up to 8. Factors means multiples that multiply to 12. It's 1 times 12, 2 times 6, and 3 times 4. The sum of the terms must add up to 8. So I'm going to put the plus sign and find out which one of these pairs gives us 8. This is 13, this one is 8, and this one is 7. So we can see that 2 and 6, 2 times 6 is 12, and also 2 plus 6 is 8. So I'm going to put 2 and 6, and therefore the factored polynomial becomes x plus 2 and x plus 6. You can FOIL this just to make sure that the polynomial matches to the original question. X times x is x squared, x times 6 is plus 6x, and 2 times x is plus 2x. And the last one, 2 times 6 is 12. You can add like terms, 6x and 2x to give you 8x. And rewrite everything else. Does it check out? X squared plus 8x plus 12? Yes, it does. So your factored version of the polynomial, the x is 2, x is 6, is correct. Let's work on a different example. Probably something similar to x squared plus 8x plus 12. So I'm just going to mess around with the symbols. What if we actually have x squared minus 8x plus 12? We're going to still use the same cross product algorithm. Beginning times end, 1 times 12 is 12. The middle term is negative 8. We want to find out factors of 12 that adds up to negative 8. So I'm going to lay out the factors, 1 times 12, and we can see that it's a negative result, so you want the 1 times 12 to both be negative. Because negative 1 times negative 12 is a positive 12, so that's okay to use, and we can do the same thing for the rest of them. So negative 2 times negative 6 and negative 3 times negative 4. The sum of the factors should give us to the middle. This was negative 13, this was negative 8, and this one is negative 7. These two do not match to the bottom part of negative 8, but we can see it's negative 2 and negative 6. So therefore, the polynomial of factored version becomes x minus 2 and x minus 6. Another one that's similar. What if I was to play around with x squared and this one becomes negative 6x? Or what if I actually do negative 6 and 2? Okay, I'm going to work with negative 4x. Still the same situation will be applied. I'm going to use the cross product algorithm. The beginning times end is 1 times negative 12, which is negative 12, and the middle term is negative 4. We want to find out factors of negative 12 that adds up to negative 4. So I'm going to lay out the terms, 1 times 12, 2 and 6, and 3 and 4. We notice that the product must be a negative, so one of the terms must be negative, but it seems like we can also apply the sign to the other side. 2 negative 6 and 3 negative 4. Now, the sum of the factors must add up to the middle term. So I'm going to put a plus sign and find out which one of these pairs gives us the middle. This one is 11. This one's 4. 1, negative 11, negative 4, and negative 1. We can see that 2 and negative 6 does give us to negative 4 as a sum. So I'm going to put 2 and negative 6. So therefore, the factored polynomial becomes x plus 2 and x minus 6. You can FOIL this just to make sure that the terms does multiply up to x squared plus 8x plus minus 12. So that's x squared. X times negative 6 is negative 6x. The inside plus 2x, and the outside 2 times negative 6 is negative 12. And then you can add like terms, that gives negative 4x, and just rewrite everything else. Does this match to what we have as the original question? Yes, it does. So therefore, your factored polynomial version, x is to x minus 6, is indeed the correct answer. Now we're going to segue, because what we've been doing are polynomials that involve 1 as the leading coefficient. But what if a was a different number? So that's where we're going to use a little bit more of a complex Chrysalis method. So I'm going to work on this. 2x squared plus 5x plus 3. The 2 that's in front of the leading coefficient should be a red flag that you must use a little bit more of a complex algorithm to find its factored polynomial version. So you'll get used to using the Chrysalis method the more that you practice on its algorithm. So these two regions are the a values, and we can see that's 2 and 2. The top, just like the previous algorithm, is the beginning times end, so 2 times 3, which is 6. And the bottom, just like the other algorithm, is the middle, so that's 5. And same question, what are factors of 6 that add up to 5? So we're going to lay out the factors, 1 times 6 and 2 times 3. And we want the sum of the factors to give us the middle. So this one is 7, this one is 5. So that matches. We're going to put 2 and 3. Now, what's different about the Chrysalis method versus the normal cross-product algorithm is that you need to treat these as fractions. And you need to simplify the fractions before getting the factored polynomial version. 2 over 2. If we were to divide 2 into top and bottom, it becomes 1 over 1. And that's the simplified version of the fraction. So therefore, it becomes 1x plus 1 as the first parentheses. The second fraction is pretty much simplified, so it becomes 2x plus 3. So this is considered to be the final answer in order to get from a complex polynomial to its factored polynomial version. We can FOIL this just to make sure that it does multiply to give us the original question. 1x times 2x is 2x squared. 1 times 3, so that's 3 with the x. The inside, 1 times 2x is 2x, and 1 times 3 is 3. Add like terms, that gives us 5x, and rewrite everything else. Does this match to what we have as the original question? Yes, it does. 2x squared plus 5x plus 3. So therefore, your factored polynomial version, which is the x plus 1 and 2x plus 3, is indeed the correct answer. Let's work on a couple more, just so we can get more practice. And granted, for these next questions, show as much work as you can. Show that you are listing out the factors of the beginning times end, and then the terms that do add up to the middle term. So I'm going to discuss this question. Granted, we have 3x squared plus 7x plus 2. Now, the 3 that's in front of the leading coefficient should be a red flag that you must use the Chrysalis method. The 3, the leading coefficient, goes on the top of the horizontal line. The beginning times end is 3 times 2. 3 times 2 is 6. The middle is the 7. And just like the same algorithm with the cross product, factors of 6 must add up to 7. So let's lay out the factors of 6. 1 times 6 and 2 times 3. It seems to be it. And we want to have the sum of the factors to give us 7. 1 plus 6 is 7, and 2 and 3 gives us 5. 5 is disqualified, so therefore you put 1 and 6. 3 over 1 is already reduced as a fraction. So we could just lay out as 3x plus 1. Now 3 over 6, we can simplify that a little bit further out. So we're going to divide 3 on the top and the bottom. So that gives us 1 over 2. So therefore the second parentheses becomes x plus 2. Granted that you can just put 1 in front of x, but 1 times x is just x. So you can just keep it as that. You can FOIL this just to make sure that your answer is indeed the correct answer by making sure that this is exactly the same what we have of the original question. Let's do one more example. So say that you have 2x squared minus 3x plus 1. And we want to find the factored version of the polynomial. We see that the 2 is the leading coefficient. So that should be a red flag that you must use the complex Chrysalis method. So we're going to put the 2 and 2. 2 times 1, the beginning times end, is 2. The middle term is negative 3. Now the question is, what are factors of 2 that can add up to negative 3? So 1 times 2 is 2. But notice that we have the negative 3 that must be the sum of the terms. So what if we put negative 1 times negative 2? Because negative 1 times negative 2, if you multiply that out, does give us to positive 2. So that's okay to use. But now we need to find a sum that matches to negative 3. So I'm going to put plus and plus. This one's 3. And this is also negative 3. That's very close, but that doesn't qualify. So we're going to use negative 1 and negative 2. Negative 1 and negative 2. Treat this as a fraction. 2 over negative 1. That's pretty much simplified out as a fraction. So we're going to say 2x minus 1. Because that's 2x minus 1. As a second fraction, the 2 over negative 2, it seems like we can still divide 2 on the top and 2 at the bottom. That gives us 1 over negative 1. So therefore the second fraction becomes 1x minus 1. Because 1x minus 1 with the second negative 1. But granted that the 1x is not necessary to write out, so we're just going to write out x minus 1 and 2x minus 1. You're welcome to FOIL this out just to make sure that this matches to the original question. So we have 2x times by x, which is 2x squared. And we have 2x times negative 1, which is negative 2x. The inside, negative 1 times x is negative x, and the outside, negative 1 times negative 1 is positive 1. Add like terms, negative 2x and negative x, which is negative 3, and rewrite everything else. We see that this matches to the original question. So therefore, the factored version of the polynomial 2x minus 1 and x minus 1 is indeed your correct version of the factored polynomial.